had 2 lessons already on inverse functions. This is now our 3rd lesson. And what we're going to do today is we're going to start talking about the inverses of many-to-one quadratic functions. So the first thing that we are going to consider is just our normal standard function f of x equals x squared. And we're going to talk about what happens when we reflect it over the line y equals x. So we've learned by now that when we reflect something over the line y equals x, it means exactly the same thing as interchanging, just get that on the board, as interchanging x and y. All right, so an inverse can be looked at in 2 ways, if you recall. Either we switch x and y around, and then what that means is that our graph has also been reflected over the line y equals x. So if we go along and we now go and draw the graph of f of x equals x squared, what does it look like? All right, so let's get ourselves a set of axes, and let's just draw a quick sketch of what this graph would look like. All right, so it's going to look something like that. Okay, so it's a parabola, it's a smiley face parabola, and it has its turning point at the origin. Okay, if we put in the line y equals x, it's going to look like this. So let's just put that in as well. We'll make it purple. Whoopsie daisy, that's not what I wanted. It's going to look something kind of like that. All right, but just 1 second. Let's just move it down a little bit because it needs to go through the origin. All right, so the purple line represents the line y equals x. Let's just get that in there. Okay, if we reflect this function over this line, it's going to end up looking like this. I'm going to draw this in a different color. Oh, that is a terrible parabola, but anyway, there we go. It's going to end up looking, not going to worry about straightening that out because it's just going to make a bit of a mess of things. It's going to end up looking something like that. That really is a dreadful looking parabola, but anyway. Okay, so if we now consider what we were talking about before, this line that I have drawn in sort of lighter purple or a red sort of color, it's going to fail our vertical line test. So let's just get a vertical line. Let's take a green one and put that on here. Here's our vertical line. All right. And if we move our vertical line over to the left-hand side, we can see that our pink line or red line cannot be a function because it fails the vertical line test. All right, so what we're seeing here is that one x value has more than one output. Okay, so therefore it is not a function. So if we want to work with many-to-one quadratic functions, right, what we need to do is we need to do something which is called restricting the domain if we want the inverse of the function to be a function. Right? Before we get into talk about restricting the domain, let's just talk about what happens. You see there's a far better diagram of what it is that I'm trying to show you. What we would do is we would interchange x and y. All right, so if we've started off with f of x equals or y equals x squared, what they've done here is they've interchanged x and y. All right, so if y is equal to x squared, then switching them around, x squared would be, sorry, y squared would be equal to x. We've switched x and y around. Now, if we want to make y the subject of the formula, right? We need to take the square root on both sides. So when we make y the subject of the formula, it can either be equal to plus or minus the square root of x. Okay, so that's exactly what they're showing us over here. Our original function, the first one that I drew, I didn't draw it very well, didn't draw the second one very well, is this yellow line over here. There's the graph of y equals x squared. Here is our reflection line, the line y equals x. And here is our reflection over that line. Let's put that in green. Okay, the one that I really didn't draw very well at all. Okay, and the green one is the one that fails the vertical line test. So it is not a function. So after we've switched x and y around, we're going to make y the subject of the formula. All right, so that is what it would look like. Okay. In order to be able to make the green line, the green graph, into a function, what we're going to do is we're going to restrict the domain. All right. So when it comes to restricting the domain, right, there are two ways in which this can be done. Okay. So there are two ways to restrict the domain. The domain, if you recall, is our set of which values? Our set of x values. So if we have a look at our Cartesian plane, all right, we see the following, all right. To the right of the y-axis, okay, this region of the Cartesian plane over here, this is where x is positive, where x is greater than 0. To the left of the y-axis, so this region of the Cartesian plane, this is where x is negative. So in other words, x is positive in quadrants 1 and 4. X is negative in quadrants 2 and 3. Okay, so what we can do is this, right? I don't know if that's big enough. Can always make it a little bit bigger. Remember to take screenshots, guys, as well. Okay, don't worry about all the writing on the left-hand side. It's really just here because I'm very bad at drawing these. And if I use these diagrams, it's a lot better for you guys. Okay, so when we restrict the domain, what we are doing, all right, is that we are either looking at where x is positive or where x is negative. So in this situation over here, we are considering the graph f of x equals x squared, and we're only considering that region of the graph where x is greater than or equal to 0. Okay, so here what we see is that x is greater than or equal to 0, and that y is greater than or equal to 0. So essentially what's happened is that the parabola has lost one of its arms. Okay, so that bit that is now a dotted line is essentially no longer there. All right, so we've restricted the domain. We now only have one arm of the parabola, which I have highlighted in yellow for you. Okay. Once we have done that, now that yellow arm that I've just highlighted in the previous diagram, that is this bit over here. Okay, so I'm not worried about the arm in quadrant 2 over here. I've restricted the domain on the original function so that when I do the inverse is also a function. So when I reflect the yellow graph over the line y equals x, I get this arm over here. Now that arm is also, it's this bit here. So I'm just going to highlight it again. The arm that I've just highlighted in green on the diagram that we were looking at, it's this bit over here. All right, so essentially, I've only got two parts of what I was looking at originally. Let me just get rid of all of that again and just show you from here what I'm talking about. Okay, so I've restricted the domain on the original function. I now have this arm of the parabola. Once I've done that, I reflect it over the line, y equals x, and now I have this arm over here. That is what we are looking at. Okay, when we go down to this diagram over here. Is everybody happy with that? Does that make sense to you?
Let's show it. Thumbs up, thumbs down, my
Thumbs.
people. Let's go. There we go. Okay, there's some that don't understand still, but let's go. Vote, everybody, so teacher Lee can know what's going on. Don't remember to take screenshot also. Okay.
Okay, so most of us are saying yes, but not all of us are saying yes. Okay, all
Yep.
right, so let's just talk about this a little bit further and let's just see how it goes, right? The other thing that I need to point out to you in this situation over here is that recall we had said that when we take a square root, all right, so in other words, when we ended up with y squared was equal to x and we wanted to make y the subject of the formula, y is going to be equal to plus or minus the square root of x. Okay, so because we are sketching the green graph in a place where y is positive, that is why we would choose the positive answer over here. So in other words, when we write y equals root x, we are really writing y equals positive root x. Okay, because x is positive and y is positive. X is positive and y is positive because we are in the first quadrant. Okay, so I'm just going to run through it one more time. Okay, in order for your reflection to be a function, we need to restrict the domain in the original function. So either we can look at that region of the graph where x is positive or equal to 0, or where it is negative and equal to 0. So what I'm essentially doing is I'm cutting off one of the arms of my parabola. Okay, so this bit on the left-hand side here that I'm coloring in, that is now no longer there because that is where x is negative. So I'm only looking at the yellow arm. And then I'm taking the yellow arm and I'm reflecting it over the line y equals x. Right, so that is the line that I have highlighted in pink. And the reason that I do this is so that the green line can also be a function. If I don't do that, then my function is not, my inverse is not going to be a function. All right, so it's called restricting the domain. Okay, now just like I can restrict the domain and I can look at where x is positive, I can do the same thing and look at where x is negative. So let's just go and consider a situation where we would do that and what that would look like. Let me just make this a little bit bigger. Can I scooch over here? There we go. Okay, so now again, let's just have a look at situation number 2. I'm going to make that a little bit bigger. So now when I'm restricting the domain to where x is smaller than or equal to 0, so my original function would be the whole thing, I'm now looking at this arm of the parabola. Here, x is negative or equal to 0, y is still positive. So I can restrict the domain to where x is negative. After I have restricted the domain, it is now possible for me to reflect this line over the line, or this graph over the line y equals x. So there's my arm. Okay, so now the arm in the second quadrant. Okay, here is my reflection line, the line y equals x. And now when I reflect that over the line y equals x, I end up with that. Okay, so here I am considering, right, where x is positive, but where y is negative. Can you see the sign of y has changed? So y is equal to negative root x, where x is positive and where y is negative. Okay, because I'm in the fourth quadrant. Okay, x is positive there, y is negative. So now when I'm doing this, right, again, when I go back to this original thing over here, right, I'm now considering the negative one. Okay, so here it comes from y squared equals x. I want to make y the subject of the formula. So I'm going to do that by taking the square root of x. X could be positive or negative, but over here, y is going to be negative. Okay, so in other words, what we have is only one arm of the parabola instead of both. Does that make sense to everybody? How are we feeling? Maybe now that we've seen both situations, it's a little bit better. Yes or no? Thumbs up or thumbs down?
There we go, Latin.
There we go.
Let's go, guys. Vote so we will know.
Okay, Sharon, y is negative because you are below the x-axis. Okay, remember below the x-axis, y is negative. Above the x-axis, y is positive. Okay, so just like in our original diagram, I was only speaking about the signs of x, but really the sign of y is also important. Let me go back to this, okay? So when we are in quadrant number 1, okay, and quadrant number 2, y is positive. Okay, so this bit over here, this is where y is greater than or equal to 0. When we are below the x-axis in quadrants 3 and 4, this is where y is negative. Okay, so remember here, positive x. Whoopsie, I'm not doing that very well. Let me just write that again. There we go. All right, so we're in quadrant number 1. We have a positive x and a positive y. Then when we're in quadrant number 2, we've got negative x, but we've still got positive y. When we're in quadrant 3, both x and y are negative. And when we go back to quadrant 4, x is positive and y is negative. So you can see there, all right, y is negative below the x-axis, positive above, x is negative to the left of the y-axis, and positive to the right-hand side. Okay, Sharon, does that make a bit more sense? Okay, so I see a lot more thumbs ups and smiley faces this time round than when we did in the beginning. Okay. All right, so now they go ahead and they go and ask us some questions. So if we have a look here, let's consider the first one. We'll do that together, and then you guys can try B and question C on your own. Okay. All right, so they give us the function f of x equals 2x squared. Can anybody tell me, how is the graph f of x equals 2x squared? How is that different to our original graph f of x equals x squared? Is there a big difference? And if so, what is it? Or is there not really much of a difference at all? Samkelo, go for it.
Hi, ma'am.
Hi,
The
Samkelo.
the difference is that the x now has a coefficient of 2.
Absolutely. And what does that do to the graph, Samkelo? Do you know?
No.
That's okay. It actually doesn't make much of a difference at all. What it does is that when you've got a coefficient of 2 or 3 or 4, what it does is it makes the arms of the parabola steeper. Okay, so as the coefficient of x approaches 0, so the arms of the parabola come out. As that number gets bigger, so the arms of the parabola come closer together. So it doesn't really make that much of a difference, but that's basically the change that we would be looking at. Okay, there's no shifting. Okay, if we were talking, yes, so gradient, Teddy, you're quite right. It makes a difference to the gradient of the arms. Okay, but it does not shift the function. If we want to move the function up or down, then we have to either add or subtract. So if I've got x squared plus 4, then I've kept the shape of the parabola, but I've moved it up 4 units. Okay, or if I say x squared minus 9, I've kept the shape of the parabola, but I've moved it down 9 units. Okay, so if I have a plus and a minus at the end, then I've either moved it up or down. Okay, but the coefficient of x squared changes the gradient of the arms. Okay, so either to make them more steep or less steep. All right, everybody happy with that? Okay, so let's have a look at f of x equals 2x squared. What do they want us to do? Well, the very first thing that they're asking us to do is they want us to sketch the graph of each function and its inverse relation. Do you see how they use the word relation? They don't use the word function because it isn't, on the same set of axes. Okay, so now this is the part that for me online is a little bit more difficult, but hopefully for you guys is a little bit easier. All right, so if I'm going to draw this graph, let me grab myself a set of axes. There we go. All right. And my graph, I'm going to try doing it this way. Rather, is going to look something like that. It's still going to have its turning point at the origin. All right. So there, I beg your pardon. Do you have a question? Okay, maybe not. All right. Let's draw in our line y equals x. There it is. There's our line y equals x. And now we want to draw the inverse of this particular function. Okay, so it's inverse relation. So now that it's been reflected over the line y equals x, that would be the one arm, and that would be the other arm over there. All right. Do you see how I'm not using function notation when it comes to the pink graph? I'm not allowed to, right? It's only after I restrict the domain that I'm allowed to use functional notation. So here, if I want to write the equation of this, I have to write this as y equals plus minus root x. I'm not allowed to write it as f of x. Okay, so that sort of notation is restricted only to functions. I cannot use it for relations. Does somebody want to ask a question, or am I just hearing things?
Yes, I think there's someone who's trying to ask a question, but at the same time. So if you have a question, please just raise your hand like this. Teachers, Lee and I can recognize you. So we can tell you to ask. Because if you ask without raising a hand, someone is talking and the other one is talking and teacher Lee is also talking. So just raise your hand and then we can give you a chance to talk.
Yeah. You're quite right, Nolwazi, because I'm busy thinking about this person talking to me. I'm not paying attention. You're quite right. Okay, I have made a small mistake here. Okay, so now when I wanted to change this, sorry, let's just fix it up. All right. So now, Nolwazi, what I would have ended up doing was this, all right, to get my inverse. I'm now going to change my x and y around. So that means I'm going to end up with x equals 2y squared, right? You're quite right. This means I'm going to end up with x over 2, okay, is equal to y squared. And now when I want to make y the subject to the formula, y would be equal to plus minus, and then this would be x over 2. Quite right. Thanks, Nolwazi. I was not concentrating. Okay. All right. So Leah Kanya, Samkelo, Tsakhfatso, Zinhle. All right. Where did I lose you? At what point were you lost?
There we go, Spilile. Well done for raising your hand.
Cool, go for it, Spelile.
Afternoon, ma'am.
Afternoon, how are you?
So, fine, thanks. How are you?
I'm fine, thank you.
So the calculations in, I think it's red. The calculations in red, is that for the two lines facing to the right?
Yes, absolutely. So what I'm trying to do, Spelile, is I'm trying to color coordinate it for you so that you can see which writing goes with which graph. So your blue graph is the original f of x equals 2x squared, and the pink graph is its inverse relation. Okay, so in other words, y equals plus minus root x over 2. Okay.
Okay.
All right. So no problem. So all I've done is the very first question where I have sketched the graph of each function and its inverse relation on the same set of axes. That's all I've done here. All right, so it's actually exactly the same as what we were talking about over here. It would look identical to this. The only difference is that the gradient of the arms would be steeper, right? But we don't need to worry about the exact measure of that when we're drawing a sketch. Okay, so how it looks over here is 100% correct. Okay, Palesa, do you have a question?
Yes, ma'am. I wanted to ask about the red, the one in the red. Will it always
Yes.
be in that direction when it says inverse relation on the same set of axes?
Yes. So Palesa, if your coefficient of x squared is positive, then it will be like that. If it's negative, it will be the other way. All right. And that's why I've got that other graph there, question C, P of x equals negative x squared. So we can have a look at what it would look like. Because obviously, if I'm drawing the graph of negative x squared, then it's now a sad face parabola. So when it gets reflected over the line y equals x, then your function would be that way around, if you can see what I'm doing. Does that make sense
Yes,
to
ma'am.
you? But we'll go
Yes.
and have a look at that one. We'll go and have a look at that one as well. Okay. All right. Okay. Tsegofatso, do you want to ask a question?
Yes, ma'am. I wanted to ask if the straight line graph with the green color, is it for the inverse of g of x, or it's
So
also part of
no.
x?
No. So the green line, I've just got rid of it now. That is your line y equals x. It's the line over which you are reflecting your function. Okay, so remember when we do an inverse function, it's the same as switching x and y, which is the same as doing a reflection over the line y equals x. So that's what I'm trying to sketch for you in green. Can you see the line that I have in pink up here? The
Yes.
line that's in pink there, the dotted line, and this line that's dotted in pink, it's that line. That's what it
Okay.
was. Okay, I deleted it, but let me just put it back there. But that's what it is. Unfortunately, I can't get a dashed line on here, which is a bit unfortunate, because then it looks like a function when it's actually, I mean, it is a function, but I mean, it's not the function that we're talking about. Okay, so your green line is your reflection line. It's the line y equals x. Okay. All right. Okay. So now what they've asked us to do is they've asked us to restrict the domain of the original function in two different ways so as to form new one-to-one functions. Okay, so they want us to restrict the domain of the original function in two different ways so as to form new one-to-one functions. So what we are finding that when we restrict the domain, what was a many-to-one function has now become a one-to-one function. There are two ways in which we can do this, right? So either we are going to restrict the domain to where x is negative, or we're going to restrict the domain to where y is positive. So that means we're going to have two different graphs. Kumutsile, do you always have to include it when sketching graphs? Yes. Yes. So Kumutsile, are you talking about the line y equals x? Yes, you would include that as well. Absolutely. You would have that on the page too. 100%. And then I see there was another question. Let's just take that from Sharon. Yes, Sharon, what's your question?
Greetings, ma'am.
Hello.
Ma'am, I want to ask about the line y equals to x. In an exam, is it always line y equals to x, or they give us
Yes.
like a different one?
No,
Oh,
no, no.
okay.
It's always going to be that line. Okay, so as far as your inverses are concerned, it's always going to be that. They're not going to give you anything else. Okay, so you don't have
Okay,
to
thank
worry.
you.
You don't have to worry about that. Okay, so I'm going to put this over here so that we can compare the two with one another. All right, let's just move this. Oh, it's moved over as much as we possibly can. Okay, so now when we want to restrict the domain to where x is positive and where y is positive, we are looking at the blue line that I'm highlighting in yellow. Okay, it now looks green because I've put yellow over blue, but that's the bit that we are looking at. So in other words, I am taking that arm of the parabola and I'm leaving it there. Okay, this line over here all right, because I've restricted the domain, right? It's still going to be the function y equals, 2x squared, but I have restricted it to where x is greater than 0 and where y is greater than or equal to 0. When it comes to the inverse of this, right, so I'm going to invert it, it's going to end up doing that. Okay, so in other words, what I'm sketching here is going to be this bit here that I'm also putting in yellow. Okay, so that's what I'm looking at. Right, so now my many-to-one relation has become a one-to-one function. Okay, it's going to pass my vertical line test. Is everybody happy with that? Does that make sense to you? So now I am allowed, right, to use functional notation here, right? This is the graph of y equals plus x over 2. And I can write this using functional notation. So I'm going to write f to the minus 1x, and it would be root x over 2. Here, I'm working where x is greater than or equal to 0, and where y is greater than or equal to 0. Okay, now let's see, there were just a couple of questions. Let's have a look. Oh, yes, Teboho, not a problem. I'll go back and do that. There you go. There's the question. And let's just see who had hands up. Samkelo, what's your question?
Ma'am, when indicating the restrictions in an exam, do you need to show like a set form of calculation, or you can just indicate the restriction?
Absolutely. You just indicate the restriction.
Okay,
Yeah,
thank you,
that's
ma'am.
it. Okay, no problem. And then Tebelo, what was your question, Tebelo?
Hello, ma'am.
Hello.
Okay, so like when they ask us, maybe let's say the inverse of a parabola is not a function, then they ask us to restrict it to be a function. How are we gonna do it?
Exactly like I've shown you here. This is exactly
Oh.
it. So there's two ways in which they can ask you to do that. So either they can ask you to restrict it to where x is positive, or they can ask you to restrict it to where x is negative. All right. So the first diagram is your original function and its inverse relation. Right. In the second diagram, I've now restricted the domain of the original function. So now the inverse relation is not a relation anymore. It's now a one-to-one function. Both of these are now one-to-one functions now that I have restricted the domain. Okay, so this diagram that I'm labeling number 2 here, this is diagram 2, this is diagram 1. This is where the domain has been restricted to where it's greater than or equal to 0. But I can do more than that. Right, so because I can also restrict the domain to where x is negative. So let's grab another, just push this over. Okay, let's grab this. Oh, man. And move it up here. And then at least we've got all three of them sitting next to one another, and then we can make a nice comparison between them. All right, so now this is number 3. Here, we're going to look at where x is negative. Right, so now we're talking about, let's get a different color. Now we're talking about the green bit. Okay, so now we're restricting the domain to where x is negative. So in other words, this arm is going to look like that. Okay, because its right arm has been chopped off. Okay, so just the left arm is now there. All right, again, I would say this is a graph of f of x or y equals 2x squared, where x is smaller than or equal to 0. If I put in my line y equals x, let's do that in a different color. It would look something like that. There's the line y equals x. And now when I reflect the green line over my line y equals x, I'm going to end up seeing that arm over there. All right, so here what I have done is I've restricted it to where x is greater than or equal to 0, but where y is smaller than or equal to 0, because I'm in quadrant 4. Okay, x is positive and y is negative. Okay, so y has changed sign. So now I can write this as f to the minus 1 of x is equal to negative root x over 2. Okay, I think somebody else had a hand up. Amahle. Yes.
Evening, ma'am.
Good evening.
In terms of restricting the range, do we
The
have to?
domain.
Yeah. Sorry, the domain.
It's
Do we
okay.
have to write it as is? Like in the way you just wrote, just above where you wrote the inverse of the x graph.
Yes, absolutely. So when you are writing the restriction of the domain, you are either writing this that I'm highlighting in pink, or you are writing this that I'm highlighting in yellow.
Oh, okay.
Okay, that's the restriction on the domain. Okay, and what's important to note here, Amahle, is you are restricting the domain of the original function so that its inverse can also be a function.
Okay, and this applies to either
This
arm of the parabola.
And this applies to either arm of the parabola, absolutely.
Okay.
Absolutely. So your original parabola is a many-to-one function. You restrict the domain. Okay, well, after you do an inverse, you've now got a one-to-many relation. All right.
Okay.
If you restrict the domain, your many-to-one function becomes a one-to-one function. Does that make sense?
Yes, it does. Thank you so much.
Okay, all right, no problem. Sorry, there's lots of words here to remember, and the order in which we use them is also important. Okay. All right. Yes, Kumutile, that's what's expected when you have to restrict. Okay, and then when you would have to sketch. Okay, so you would have to show the arm of the original parabola in the correct quadrant. You would then have to show the line y equals x, and you would also have to show the inverse as well. Okay. The other thing that they can also get you to do is they can get you to work out the coordinates at the point of intersection. So for example, now we can't do that in situation 3, although I suppose they do intersect at the origin, but that would be the only point. But what I'm talking about here is this point here in number 2, where these two cross over one another. That's the other thing that they could do. So they could expect you to work out the coordinates at that point of intersection. Does anybody have an idea? I'm just putting the line y equals x back in here. Does anybody have an idea of how you would do that? Amahle, how would you do it?
You'd have to use simultaneous equations.
Absolutely. And you know what would be the easiest thing here, Amahle, to be honest with you, is if you worked with the original function over here and you worked with that one over there, that would probably be the easiest thing. And then you don't have to work with the root. Okay, because at that point, at that black dot over there, remember, it's the intersection of 3 things. It's the intersection of your original function with your inverse, as well as the line y equals x. So that's probably the easiest way for you to do it. So for example, what I could do here is I could say, well, if y equals 2x squared and y equals x, then it means that 2x squared will be equal to x at that particular point. If I take x over to the other side, because this is quadratic, so I'm going to end up with 2x squared minus x equals 0, I can now take x out as a highest common factor. That would leave me with 2x minus 1 is equal to 0. Okay, so either x would be equal to 0, or, sorry, I should have put the or in, or x is going to be equal to, take the 1 over to the other side and divide by 2, it would be equal to 1 over 2. Okay, so this point of intersection over here would be at 1 over 2 and 1 over 2, because remember, y equals x. Right, so that's something else that they could also ask you to do. How are we feeling at this point, Matrix? Is this making sense to you?
Let's indicate, my people, Thanks, Bonge no Betsutu. There we
Oh,
go.
good.
We
Oh, good.
understand.
We
Yeah.
understand. All right. Yeah, it takes a little while in the beginning to get used to what it is that we're talking about, but hopefully the use of color also helps you guys as well. Oh, that's nice to see. Everybody good. Good, good, good. Oh, I'm so glad. All right, so let's go back here and go and have a look at what they asked. Okay. All right, so we've done this. We have sketched the graphs. We've done this bit as well. We've sketched the graphs of each new function and its inverse on the same set of axes. And then, hence, rewrite the equation of each inverse function in the form using functional notation. So this is very important. I just want to emphasize this again as well. All right, so you are only allowed to use this notation, all right, if the graph is a function. All right, so as I was saying to you in the beginning, in picture number 1, all right, I was not allowed to use functional notation here, right, for that y. I cannot write f to the -1 of x because that graph, that inverse, is just a relation. It is not a function. Remember, it fails the vertical line test. It's only once I've restricted the domain of the original function that I'm now allowed to use functional notation. All right, so as I have done here, this might be a little bit small. I'll write it again. So f minus 1x, and this was equal to positive root x over 2, and as I had done over here as well. Okay, so f to the -1x of minus root x over 2. Okay, now I think what I'm going to do is give you guys an opportunity to do, I'll just get rid of the green because I think it's a little bit distracting, is I'm going to give you guys an opportunity to do the same thing with graph B. Okay, so you're just going to do exactly what I've shown you over here with graph A. All right, if you are a fast finisher, then I suppose you can also try C, but I don't know if everybody's going to be able to do that. And I do want to talk to you about this because this one over here is, as we were talking about a little bit earlier, this graph is the sad face. So I definitely want to do that one with you. But yeah, let's try B for now. And then when we've marked that, then we'll have a look at C together. I think that's the best way for us to do it. Okay, everybody, ready, steady, go.
Let's go. I like the fact that we already did like an example, so this one should be a little bit nice for
Yeah,
us.
it should be quick and easy enough. That's fine, Amashle, not a problem. I'll do that. There you go. Hopefully you've got that, Amashle. No problem. Oh, cool. All right, and I'm just going to go back to the questions. There we go. Oh, wow. Good, Nawazi. Well done. Okay, so once you've sketched B and its inverse relation, then you can do the restricting of the domain, okay, so that you end up with Well done, Amahle. Yes, Tsepi, so that's the whole idea. Okay, so in other words, what you are doing with B is exactly what I showed you. So I've done 1, 2, 3, and 4 in all these diagrams that I have done over there. So that's basically what I'm expecting you to do. You don't have to find the coordinates at the point of intersection though. Okay, and then obviously here at the bottom where it said write down the domain and the range of each, then what we've done, I've written the domain and the range of the inverse, the domain and the range. We should be able to do the domain and the range of the original functions without any problems.
Let's go. I see some of those saying done, done, done. You guys done to until question 5, it looks like.
That's good. Okay, Samkelo, that's great. So would we say that we're ready to look at the answers now? Cool, Tina. Cool, Dikaledi. Well done, Tabelo. Cool, little. Nice. All right. So there's a whole bunch of you that are saying that you're done. All right. That's great. Because what I wanted to do is just spend a little bit of time talking about the graph f of x equals negative x squared. So, all right. So this is what it should have looked like. Okay, let's just get that guy out the way. This is what you should have ended up with. Oh, hang on. That's the wrong one. Hang on. Oh, no, that's not the right. Sorry, guys. Just 1 second. Okay. All right. So this is what your graphs should look like. Sorry, let me just do this quickly. There we go. There we go. All right. So as far as your answers were concerned, there are your 3 graphs. Okay, so part number 1, right there is our original function, y equals 3x squared. That's this one here in pink. And our inverse relation, y equals plus or minus root x over 3. That would be that graph over there. Okay, and then when we restricted the domain to where x was positive, we would have ended up with this arm of the original function, and we would have ended up with that over there. And again, if we restricted it to where x was negative, we would have this over here, and we would have that over there. Okay, so let's just get this on the page. As far as our inverse function is concerned, for the middle situation, g to the minus 1, of x would have been positive root x over 3. Okay, over here, our g to the minus 1 of x would have been negative root x over 3. Over here, our domain is x is greater than or equal to 0. Our range, y is greater than or equal to 0. Over here, our domain is x is greater than or equal to 0. Our range, y is smaller than or equal to 0. Did that go okay? Is that what it looked like? Are you happy? Is it making sense? All happy? Yes. Oh, good. Oh, I'm so pleased to see that.
Yes,
Happy.
it
Good.
is.
Oh, good. That's lovely. Well done, everybody. Well done,
Mm.
well done, well done. Okay, I can see there's somebody who's put their hand up. For some reason, my participants have disappeared. I don't know why. Okay. Oh,
Can just
Amahle. Sorry, there we go.
unmute.
There we go. Okay.
Ah,
Amahle,
okay.
go for it.
Ma'am, do we have to do 3 separate graphs, or can we just do one graph and then write the information next to the relative arm of the parabola?
Amahle, I'm sure you can do that. You know, the thing is that this is not the sort of question that they would give you in a test where they would ask you to do the restriction on both. You know, in a test, they would probably only ask you for one anyway. They probably wouldn't ask you for both. Okay, but yes, that's absolutely fine.
Okay, thank you.
Okay, no problem. Okay, and then the next person, I can't see your name. It's 1VTCET. Who's that? You're welcome to unmute and ask. Okay, oh, I see here you've said, ma'am, how do we sketch the original graph? Okay, all right. So the original sketch is this one over here on the left-hand side. This one that I'm putting the circle around, that's your original function. Okay, so your graph y equals 3x squared is going to be a happy face parabola with its turning point at the origin. Okay, so that's something that you would have done all the way back in grade 10 for the very first time. All right, so there's no points to plot there. What you just want is the correct shape, and you want to make sure that it goes through the origin. Okay. Well, when I say it doesn't have to be accurate, yes and no, all right? So in other words, if you draw it, there's a set of axes, right? So let's say you come along and you draw your function like that. Okay, everybody's happy. If Yolanda comes along and she draws the same function, but she ends up drawing it like, sorry, I don't know why my thing is doing this, and she ends up drawing it like that. Okay, that's really not the right shape because the lines here, that really irritates me when the computer does this. Sorry, guys. Hang on. Okay, so there we go. So you come along, you draw your function like that, all good. All right. Yolanda comes along and she draws her function like this. We're still happy. If I come along and I draw my function and mine looks more like that, it's still all good. All right. So for what we're doing now, all three of those would be correct. Okay. They've all got their turning point at the origin, and it's the correct shape. It's happy face. Okay. I hope that answers your question.
Yippee.
Yes.
But
So if you are asked to find the coordinates on the original function, are you talking about at the point of intersection of the two? All right, the easiest way to do it is to not use the inverse relation. All right, because then you're going to be working with a square root. So remember, at this point over here, it is the point of intersection between the line y equals x as well as y equals 3x squared. So that's just easier for you. Okay, so I would solve simultaneously using those two equations. I would make 3x squared equal to x and solve it that way, because it's just going to make your life so much easier. Okay. The
I'm just
coordinates of,
gonna wonder.
yep, go for it, do the
So,
poll.
yes. And I'm
Okay,
looking at the time.
so
Thank you,
yeah, no,
people.
absolutely. Dick-Lady, when you say the coordinates of both, there's only one point of intersection. So it's the origin and that point in blue. Okay. And all three graphs go through all those points, go through both those points. Okay. So that's why this method that I'm showing you here in blue will work. Okay. It's going to be the easiest thing for you. Okay. Hopefully everybody is okay. Yes, that's fine. There they are. All right. And then the other thing that I'm also going to show very quickly before disappearing is the answers to question C, which was in pink. Okay, so that you guys can go and practice that, and then you've got an opportunity to mark it on your own as well. So that's this one over here. We unfortunately didn't get a chance to answer this, but there are the answers as well. Okay, so that's what those graphs would have looked like. Okay, so take a screenshot of that too. Yes, always do that, Zahufatso. John, no. So the when you say do we calculate any points, it would only be the points of intersection. All right, and you would do it the way that I showed you.